The automatic ventricular volume estimator, AVVE, is our first proof of concept algorithm to test the PAC's analytical capabilities empowered by the vehicle created in the first video of this set of 3. The AVVE is to be fully automatic since the PAC's pipeline does not accept human interaction. That is why we have used artificial intelligence to accomplish segmentation in a highly variable and non-uniformized environment as it is the clinical imaging one. The AVVE extracts 4 features from the images to assert separation of the ventricles, the normalized distances, and the histogram classified intensities, HCI, neighboring, called NAV, and cardinality, which we call CARD. In the learning stage, the mask of the data should be provided to create the estimator, which learns from every voxel in the images and thus affects separation of the structures in a voxel-based manner. Once the estimator is created, we can use it to segment the ventricles in any new subject, regardless of its acquisition parameters, or if the field of view does not hold the whole brain, which is also used in hospitals. After the AVVE has estimated the mask, getting the numbers is straightforward for the pass. Remember that the AVVE returns 0 or 1 depending where the estimation concluded that the visited voxel does not belong to the ventricles or belong to the ventricles respectively. So, calculating the volume is just a matter of counting ones. Here we have the paths to the images, and I will call the library that we have created as the AVVE core. The loaded data has headers, but we are interested only in the matrices that represent the images. We have access to those matrices with this command. Then we import a Python package to facilitate matrix operations and zoom all the boxes in the image. Only voxels with 1s in the max will contribute since the other voxels hold 0 as a value. We divide by 255 since the images are binary but created at 8 bits. Therefore, 0 is 0, but 1 is 255, meaning 2 to the power of 8 minus 1. Now, in voxels in pre and voxels in post, we have our max voxel counting. But remember that these images are clinical and have different resolutions. So we need to know how big is each voxel. We do it like this. We know the resolution in the pre and the post procedure. We can provide then the volume in millimeters by getting the product of the voxel counting and the resolution, like this. The numbers are now in our console and are used to create the report that looks like this one on a screen. As explained in video 1, the report is sent back to the PACS using our vehicle and bringing to life the one-click medical applications concept. This vehicle can be used to implement limitless analytical procedures.